Welcome back to Chapter 1, Differentiation. And here we will look at all sections 1.1 through 1.8. And again, I will present core problems, very important problems from each section. Section 1.1, it entitled Limits, a Numerical and Graphical Approach. So 1.1, Limits. A numerical and graphical approach. I'm sure you read through the section so far by now. So I would like to look at problems 27 through 34. They are on page 107. Again, you cannot read from my graph, so please open the book on that page and look at the graph. I'm going to copy an approximate graph. So here how the function looks like. And we have something like this. And then on the other side, something like this. Okay, so this is f of x. We have to answer several questions. Use the following graph of f to find each limit. When necessary, state that the limit does not exist. So problem 27. We are asked to find limit. Sx approaches -3 from either side. Actually, they denoted this by uppercase. It's not important. From the left-hand side of -3. Well, this is the point where x is -3. And from the left-hand side, as well as from the right-hand side, the function values approach the same number. The function does not have to be defined here. It happens to be. So both limits equal 5. The function values from the left approach 5. The function values from the right approach also 5. So the limit from either side is 5. Problem 28, same page. Limit of f of x as x approaches 2. Limit of f of x as x approaches 2 from either side. 2 from either side is this point. Again, the same situation. Function values from both sides approach the same number, and it happens to be 4. So from the left, approach 4, from the right, approach 4. Again, the function does not have to be defined at 2. It happens to be. Problem 29. We're asked to find limit of f of x as x approaches -2 from either side. Okay, it happens that from the graph this is -2. And now we see there is a problem. The function values from the right approach on the graph 2, function value 2. And from the left, right here, they approach 4. So I will have to write limit of f of x as x approaches -2 from the left with function values smaller than -2 is 4, and limit of f of x as x approaches -2 with function values larger from the right, larger than -2 is 2. Therefore, from here I conclude that limit of f of x as x approaches -2 from either side does not exist. Does not exist. Problem 30. For the same function, we're asked to find limit of f of x, xx approaches -5. It happens that -5 on the graph is right here. The function values from the left and the function values from the right, they both approach 0. 31, 4 from either side. Okay, so 31 limit of f of x as x approaches 4 from either side. It happens that this is 4. The function is not defined at 4, however, that does not mean anything when it comes to the limit. The function values from the right approach 2 and from the left approach 2, therefore the limit is 2, although the function is not defined at 4. At 6, the same thing. At -2 from the right. Yes, we already answered all questions. I would like to continue now with 1.2, algebraic limits and continuity. I'm again assuming that you went through this section, you read the section, you did the examples in the section, so I am moving on to page 117, and I selected a couple of problems from there, so this is my page 2 now. I would like to look at problem 25 on page 118, and that is limit as x approaches 1 from x to the third minus 1 divided by x minus 1. Every time I'm asked to find a limit, like this one, I will first plug it in. I know I'm not allowed to. X approaches 1 specifically means x does not equal 1. However, I will have to plug it in to see what type of limit this is. 1 minus 1, 0. 1 minus 1, 0. There is always hope for 0 over 0. There is hope that the limit exists. There exists hope. So there is hope that the limit exists. In the situation of a number, not 0, divided by 0, there is no hope that the limit exists. A number over 0 will always change into infinity, negative infinity, or it does not exist. In this case, there is hope. 0 over 0, not necessarily the limit will exist, but there is hope. So what I will do next is factor the numerator. The numerator is the difference of cubes, which is a cubed minus b cubed, a minus b, a squared plus ab plus b squared. So please review the formula. It should be either in the front cover or the back cover of your book. Of course, if we are factoring the sum, the sequence of signs changes. So this is x minus 1, x squared plus x plus 1 over x minus 1. Since x does not equal 1 for sure, I am allowed to simplify a common factor. And now the next step is limit as x approaches 1 from x squared plus x plus 1. Again, I'm allowed to replace it. It's a polynomial function. I will replace x by 1, and the limit will be 3. In problem 27 on the same page, I have limit as x approaches 25 from the square root of x minus 5 over x minus 25. Well, it happens that I get the same situation, 0 over 0, and there is hope. Not necessarily the limit exists for sure, but there is hope. And in this particular situation, I have several possibilities. One possibility, which is factoring this, the denominator, using a squared minus b squared, which is a plus b times a minus b. That's one way. The other way will be to rationalize the numerator multiplying the numerator and the denominator by the conjugate of the numerator. So it doesn't matter to me. I think it would be easier if we would rationalize the numerator, or if we factor the denominator is the same thing, is the square root of x plus 5 and the square root of x minus 5. So let's go this route. So this is possible, very easy. Let's go this route. However, I think it would be easier for you to do that. When we multiply these two, it's a minus b times a plus b. I'm using the same formula, so this is x minus 25, and then x minus 25, and the square root of x plus 5. These two, again, go away. They are the same factor. So this limit now is limit as x approaches 25 from either side, from 1 over the square root of, x plus 5. When I replace, I'm allowed to. The square root of 25 is 5. 5 plus 5 is 10. So the limit is 1/10. I would like to continue with problem 29 on the same page. So that's my page 3. So 29 on 118. And that is limit as x approaches 1 from either side, and x squared plus 5x plus 4 and x squared plus 2x plus 1. So this is limit as x approaches 1. I plug it in. 1, 1. I copied incorrectly, sorry, it's negative 1. So 1 minus 5 plus 4 is 0. And 1 minus 2 plus 1 is also 0. So the limit from the top and the limit from the bottom, in the case of 0 over 0, there is hope. We'll see what happens. I factor the numerator into x plus 1 and x plus 4, and I factor the denominator into x plus 1 squared. I realize that I can get rid of one of those factors, and that is an x plus 1. However, now the new limit becomes limit of x plus 4 over x plus 1 when x approaches negative 1, but this is a number which is 3 divided by 0. So there are here 3 possibilities: infinity, negative infinity, or DNE. Let's check what happens from the left and from the right. So limit as x approaches negative 1 from the left of x plus 4 over x plus 1, and also limit as x approaches negative 1 from the right of x plus 4 over x plus 1. Negative 1 from the left means with numbers from the left of negative 1, like negative 1.1. When I plug this negative 1.1 in here, I get a positive number at the top and a negative number in the denominator. I know that it has to be one of these, but positive over negative is negative infinity. Therefore, the limit from the left is negative infinity. Now, in this situation, with negative 0.9, which is a number to the right of negative 1, this top will still be positive, but also the denominator will be positive. Therefore, the positive over positive will give us negative infinity, positive infinity. However, because left and right are different, and because they are infinities, even if they were the same, the limit would not exist. But in this case, I cannot write positive infinity for the limit from either side of x plus 4 over x plus 1. I cannot write negative infinity. I cannot write positive infinity. I must write DNE from either side. The other problem that I would like to look at is problem 57. It talks about continuity on 119. Is the function given by f of x, which is a piecewise defined function, 1/3 x plus 4, and 2x minus 1, for x less than 3, and x greater than or equal to 3, is it continuous at x equals 3? So continuous or not at x equals 3. And to explain why. The definition of continuity at the point. Definition of continuity at a point. Here it is. Limit of f of x as x approaches a from the left must equal limit of f of x as x approaches a from the right and must equal the function value at that point. This is a crucial definition. Super important. So for the given function, I will have to determine this. I will have to determine this. I will have to determine this. If all three are the same, I'll say yes, continuous at 3. If one of them does not equal the other two, or there are 3 different numbers, who knows? If they're not all the same, I will conclude that the function is not continuous at x equals 3. So this is my page 4. And I have to calculate or determine limit as x approaches 3 from the left, which is of 1/3 x plus 4, because the limit as x approaches 3 from the left, I have to use this branch. So when I plug it in, 3 times 1/3 is 1, 1 plus 4 is 5. Now limit as x approaches 3 from the right, I have to use the other branch for 3 from the right of 2x minus 1. 3 times 2 is 6, 6 minus 1 is 5. And now I have to determine f of 3. And there is only one branch where I plug in 3. Not this one, but this one. 2 times 3 is 6, 6 minus 1 is 5. Therefore, I will conclude, since all these 3 numbers are the same, 5, 5, 5, f is continuous at x equals 3. Section 1.3, average rate of change for any function is nothing else but the slope of the line passing through the given points. So on page 129, 130, I would like to look at 2 different problems. One of them is 29, once again on page 129. Baseball ticket prices. Based on the data from Major League Baseball, the average price of a ticket to a Major League game can be approximated by P of x equals 0.03x squared plus 0.56 x and then plus 8.63. Where x is the number of years after 1991. So x equals 0 is 1991. And P of x is in dollars. So P of x in US dollars. Find P of 4. So in part A, P of 4. In part B, P of 17. As we did in the previous chapter, I will put in the function in y equals, and that will be 0.03 x squared plus 0.56 x and plus 8.63. I'm checking 0.03 x squared plus 0.56 x plus, okay, go to second and table, and I will plug in, they say 4 and 17. So when x is 4, I got 11.35 and 26.82. So at this point we have 2 ordered pairs, 4, 11.35 and 17, 26.82. In part 3, they're asking us to determine that difference. Okay, so they want us to find P of 17 minus P of 4. And in part D, They're asking us to find the average rate of change between the year 4 and year 17. So that is f of 17, or in this case p, forgive me, it's denoted by p of 17 minus p of 4 divided by 17 minus 4, which is nothing else but y2 minus y1 over x2 minus x1, which is the slope of the line passing through those points. So when we subtract 26.82 minus or 11.35 from 26.82, I got 15.47. So then 15.47 divided by 13, I divided by 13, and I get 1.19. This is dollars per year. The average rate of change is always a ratio, and the result has to have a measurement unit given by 2 pieces. The measurement unit for the top, which is dollars, over the measurement unit of the denominator, which is year. So they're also asking us to interpret the results. So this is the average price of a ticket increases. The average price of the ticket increases by $1.19 per year. So the average increase rate per year for a ticket is $1.19 per year. The other problem I would like to look at here is problem 33 on page 130. And I think I got to page 5. So this is problem 33 on page 130. Suppose that Sports Styles Incorporated determines that the cost in dollars of producing X cell phone sunglasses is given by. So they're giving us a cost function which is negative 0.05 x squared plus 50x. And they're asking us to find C of 301 minus C of 300 over 301 minus 300. And of course, that will be the cost of producing the 301st unit. Cost, or the average cost of producing the 301st item. So again, I will plug it in the graphing calculator in y equals. I clear negative 0.05, oops, negative 0.05 x squared plus 50x. And then I punch in 301 and 300. So let's see what we got. And we got 10519.95 minus over 1. So the difference is 19.95 per unit. So the cost to produce the 301st unit. Assuming that, and I'm hoping that you read through section 1.4, you did the examples, and you're ready for section 1.4, differentiation using limits of difference quotients. We talked about difference quotient even in the previous chapter. So 1.4, differentiation using limits of DQ, difference quotients. I would like to look at 2 examples here. Problem 13 on page 142. We're given a function which is f of x 2x squared plus 3x minus 2. And we're asked to find the derivative of this function. That's what all I'm interested in here. Find f prime, which is the limit as h approaches 0 from the difference quotient. That was one of the reasons we reviewed the difference quotient in the previous chapter. So first I have to determine this. That's my first step. That's my first step, and then this. That will be my second step. So I have f of x, h is just h. I have to determine f of x plus h. F of x plus h is 2x plus h squared plus 3x plus h minus 2. You remember a binomial squared has 3 terms. 2x squared plus 2xh plus h squared plus 3x plus 3h minus 2. Finally, I will distribute 2. 2x squared plus 4xh plus 2h squared plus 3x plus 3h minus 2. And now I'm ready to simplify the difference quotient. So f of x plus h minus f of x divided by h, which is 2x squared plus 4xh plus 2h squared plus 3x plus 3h minus 2 minus, sorry, I ran out of room, minus 2x squared minus 3x plus 2 divided by h. That's our f of x. This is f of x plus h, and this is minus f of x. I distributed -1. I'm looking forward to simplifying all terms that do not have h in them. And now I see that there are 3 remaining terms, all have h in common, and I will simplify with the h in the denominator, but not before I factored it out. So I'm on my page 6. So this is, h comes out 4x plus 2h plus 3 divided by h, which goes away, 4x plus 2h plus 3. Finally, I know that f prime of x is the limit as h approaches 0 from this, which is the difference quotient. When h approaches 0, this quantity approaches 0. Therefore, the derivative of this function for any x is given by 4x plus 3. I would also like to look at problem 21 here. So 21 on the same page, 142. And find the equation of the tangent line to the graph of f of x, which is 4 minus x squared, at the given points -1, 3, at the point 0, 4, and at the point 5, -21. I know that the slope of the tangent line is the same thing with f prime of x. So therefore, I have to find again the limit as h approaches 0 from f of x plus h minus f of x divided by h. Let's this time put it in as is and not simplify it aside. It's not a problem. You can do it either way. So f of x plus h is 4 minus x plus h squared minus the function itself and plus h. I distribute -1 to the function. I get -4 plus x squared. Of course, these two go away. Limit h approaches 0. I have to square first and then distribute -1. I know I get 3 terms and distribute -1. Negative x squared, -2xh minus h squared, and plus x squared over h. The 2x squared goes away because one is positive and one is negative. Of course, I will factor out h. negative 2x minus h divided by h. And then when I plug in 0, I get negative 2x. Now, from here, I am given three different x values. So the slope at negative 1 is f of negative 1, which is 2. The slope of the tangent line to the graph of the function at 0 is f prime of 0, which is 0. And then the slope is f prime of 5, which is negative 10. And now I will be able to determine three equations. So y minus y1 equals the slope times x minus x1. I'm going to only do one. You can do the other two. I'm going to do the last one. So the point is 5 comma negative 21. 5 comma negative 21. And the slope is negative 10. So y minus minus, y plus 21, negative 10, x minus 5. I distribute negative 10x plus 50 and subtract 21. So y equals negative 10x and plus 29. And I think that should be it for 1.4. Let's move on to 1.5. And 1.5 deals with differentiation techniques, the power and sum difference rules. So differentiation techniques. Oh. Too fast. Writing too fast. The power and sum difference rules. Okay, that is 1.5. I'm hoping that you went through the section and read, and now you're ready to work on a couple of problems with me, like problem 30 on page 154. And here's the problem. We are asked to differentiate. One thing I would like to mention, that this is the same thing. There are two different notations. This is the Leibniz notation, and this is the derivative notation. They are both the same thing. And we are given in 30, we're asked to find d over dx of the function negative the fourth root of x to the third. We know the power rule, that is x to whatever power, and this is a number. This is the same with n times x to n minus 1. So therefore, what we recommend here is that we replace the function by this notation, knowing that the nth root of a raised to the mth power is a raised to m over n, so 3 over 4. And now we are applying the power rule, and that will be negative 3/4. I have to bring down negative 3/4 times negative 1, negative 3/4 times x2, 3/4 minus 1. But 3/4 minus 1 is nothing else but negative 1/4. And we have another rule, a to negative n is the same with 1 over a to the nth power. So I have to continue and write negative 3 over 4 x to 1/4. I can go back to a radical notation as well. And that's the final simplified form. Also, problem 38 on the same page, f of x equals 2 over 5x to the 6th. It is recommended to rewrite it as 2/5 times x to negative 6. And when we find f prime, we have 2 divided by 5. We bring 6 down and subtract 1 from the power. We multiply 12/5 x to the 5th. And this is final. Yeah, I would like to also look at 56, where the function is the cube root of x plus the square root of x, which is better if we write it as 1/3 plus x to 1/2. We are determining y prime or f prime of x or dy over dx. They all mean the same thing. 1/3 times x to 1/3 minus 1, which is negative 2/3, plus 1/2 times x to 1/2 minus 1, which is negative 1/2. So 1 divided by 3, we bring this down, it's the cube root of x squared plus 1 over 2 the square root of x. And this is the final form. However, they are asking us to find dy over dx, and this is a very important notation, evaluated when x is 64. So this is the same thing. So we have the expression, but now we're asking us to really replace x by 64. So 1 divided by 3, the cube root of 64 squared, plus 1 divided by 2, the square root of 64. Now, we know that the square root of 64 is 8. And the cube root of 64 squared, 64 is 4 cubed. Everything squared will be 4 to the 6th. The cube root of 4 to the 6th is 4 squared, 6 divided by 3. So this is 16. So as the final simplified form, we have 1 over 3 times 16 plus 1 over 2 times 8. 1 over 48 plus 1 over 16. We have to multiply it by 3. So it's 4 over 48 or 1 over 12. The final simplified form. I would like to look at a word problem here. Problem 91. And I'm on page 9. So let's look at problem 91 on 156. It's entitled heart rate, and we are given R of V, which is 6,000 divided by V, or 6,000 times V to negative 1, can be used to determine the heart rate. So R is the heart rate in milliliters, not a rate of change, but it's of a person whose heart pumps 600 milliliters of blood per minute, so milliliters per minute. And V is milliliters of blood per beat. Okay, and we have a graph there if you want to look. Find the rate of change of heart rate with respect to V, the output per beat. So, of course, that will be nothing else but R of V prime, R prime of V, which is 6,000 times negative 1 times V to negative 2. So negative 6,000 divided by V squared. In part B, we're asked to find the heart rate. So we're asked to find the heart rate at V being 80. We'll determine in a minute. And find the rate of change now. R prime of 80. I grab my calculator. So 6,000 divided by 80. And I got 75 measurement unit. So this is 75 milliliters per minute. And then negative 6,000 divided by 80 squared, which gives us negative 0.9375. And now the measurement unit is beat per minute per milliliter. Now, I'm hoping that you looked at section 1.6, the product and quotient rules. So if we have a ratio of two functions or a product of two functions, and we are asked to differentiate the product and the ratio, here's what we need to do. For the function, for the product, f times g plus f times g prime. For the ratio, it's the same thing, but with minus at the top over the denominator squared, not differentiated. So I would like to look at a couple of problems here as well, like 35 on page 164. We are given f of t as t plus 2 over t multiplied by t squared minus 3. Of course, coming back here for 1 second, these are super important formulas. Very, very important. So yes, I can distribute and not have to use the product rule, but I'd like to practice the product rule. So f prime of t will be the first function prime. T prime is 1. 2 over t changes into 2 times t to negative 1. And when I differentiate this, I get negative 2t times negative 2t to negative 3. So 1 minus 2t to negative 3 multiplied by the second function with no change. So f prime is this, and g is this, plus f, which is this, t plus 2 over t, multiplied by the second function prime, which is only 2t. Yes, now I have to distribute and try to simplify as much as I can. So 1 distributed to these two terms is t squared minus 3. Negative 2 distributed here will be negative 2 t to negative 3 times t squared. Copy the base, add the exponents, t to negative 1. And plus 6t to negative 3. Now 2t distributed, it gives us 2t squared. And 2 over t times 2t is plus 4. So finally, 2t squared with t squared is 3t squared. 4 with negative 3 will be positive 1. And this will be plus 2 over t plus 6 over 3 cubed, t cubed. And that is final. I would like to look at a ratio now. And let's say 47 on the same page. And this is my page 10. So 47 on page 164, I have g of t, which is negative t squared plus 3t plus 5 over t squared minus 2t plus 4. And we're asked to find the g prime of t. I differentiate the top function first, negative 2t plus 3, multiplied by the denominator, minus, I copy the numerator, multiply by the denominator prime, which is 2t minus 2, over t squared minus 2t plus 4, everything squared. Yes, I have to do everything to simplify it if I can. So the denominator cannot go anywhere. Do not try or attempt to simplify anything. Negative 2t distributed here. Negative 2t to the third plus 4t squared minus 8t plus 3t squared minus 6t plus 12. Now I distribute 2t to these three terms, keeping in mind that there is a negative sign. Plus, because there is minus here as well. 2t to the third. And then minus 6t squared, and then minus 10t. Minus 1, 2, 3 negatives. 2t squared, and then plus 6t minus 10. I'm checking my work. Negative 2t cubed, correct. Minus, plus 2t squared, yes. Minus 8t, yes. 3t squared minus 6t plus 12. Now, 2t distributed here will be positive. Distributed here will be negative. Distributed here will be negative 10t, correct. So now, 2 times negative 2t squared plus 6, and then plus 10. So negative 2, these two will cancel out. It is negative 2t squared. Now these two again will cancel out. It's positive 6, and the same thing with positive 10. I'm hoping that some terms will go away, and some of them I see they do. So this is 7. Is there anything else? These two. I don't see anything else for now. So then, t squared. So this is 7 t squared, but this is negative 8 t squared. So a negative t squared. Now I'm collecting the terms with t. And this is this and this. I don't see anything else. So negative 18t. And now I'm looking at the free terms, and I have a 12 and I have a positive 10. So it's positive 22 divided by t squared minus 2t plus 4, everything squared. I would like to move on to 1.7, and I'm hoping this is a very important section, the chain rule. And it deals with a function inside a function. So for example, if I have f of another function, so f is the outer and g is the inner, then when I differentiate f of g, not multiplied, it's f of g, then I have f prime of g of x multiplied by g prime. Now if I have this time a function raised to a power, and I want to differentiate this, then I have n times f to n minus 1. But since this is not plain x anymore, I have to multiply by the inner function prime. Outer function prime times the inner function prime. When I differentiate the outer, which is the power, n times f to n minus 1, but now I differentiate the inner function and I get f prime. Two super, super, super important. And I'm hoping that you read through the chapter and you worked on the problems and examples and the odd number problems, and I would like to show you a couple of situations that are very important. Okay, so this is my page 11. I'm on page 30. Oh, forgive me. Problem 30 on page 174. And we have f of x, which is the fourth root, actually, of x squared minus 5x plus 2, which can be rewritten as x squared minus 5x plus 2 to power 1/4. Here it is. This is the inner function, and this is the outer function. So when we differentiate, we have to use the chain rule. So f prime of x is, I differentiate the outer function, which is the power, in parentheses, x squared minus 5x plus 2, 1/4 minus 1, which is negative 3/4, times the inner function prime. This is the inner function, 2x minus 5. I'll try to a little bit simplify it or condense it if possible. But I can't do too much. I would like to look at 42 as well. Same page. F of x equals 5x minus 4 to the 7th power and 6x plus 1 to the 3rd power. So when I differentiate f prime, I have to use the quotient rule. Top function prime, 7 times 5x minus 4 to the 6th, times the inner function prime, which is 5, times the second function, which is the denominator, minus the top times the denominator prime, 3 times 6x plus 1 squared, multiplied by the inner function prime, which is 6. Everything over 6x plus 1 to the 3rd squared, which means power 6. I need to factor the greatest common factor in the numerator. I see 5x minus 4 appears in both terms. I also see 6x plus 1 appearing in both terms. So first I will rearrange a little bit. 7 times 5, 35. 5x minus 4 to the 6th and 6x plus 1 to the 3rd minus 18. 5x minus 4 to the 7th and 6x plus 1 squared. Now I'm ready to factor out the greatest common factor, which is 5x minus 4 and 6x plus 1, but we have to discuss the powers, their exponents. So power 6 and power 7, the smallest is power 6. Power 3 and power 2, the smallest is power 2. Has to come out. So now what is left? All these are out. A 35 is left inside. And from these 3, I took out 2. So 6x plus 1. Now I'm here, minus. 18 is out. So from the 7, I took out 6. 1 is still left inside. And those 2 are completely out. I have to combine like terms, and of course, I will simplify. 6x plus 1 squared with 6x plus 1 to the 4th. So finally, what do I get? So this is my page 12. I get 5x minus 4 to the 6th. And then I get 35 times 6. And that's 73 times 210. X plus 35 minus 18 times 5. And that's 90. I'm lazy. And plus x plus 18 times 4, which is 72. And 6x plus 1 to the 4th. And finally, I get 5x minus 4 to the 6th. And then plus, multiplied. 210 minus 90. And then I get 120 x. And then plus 107 over 6x plus 1 to the 4th. This is multiplication. And this is final. I will also like to look at some word problems, like compound interest, but before that, let's look at 61. 61, we have f of x, which is x squared over 1 plus x to the 5th power. They're asking us to do two things. Use the quotient rule and use the power rule to show that when we differentiate either way, the answers have to be the same. So let's use the quotient rule first. F of x, the top function prime is 2x 1 plus x to the 5th minus x squared times the bottom prime, 5, 1 plus x to the 4th times the inner function prime, which is 1, over 1 plus x to the 5th squared, which is power 10. Of course, like before, I will factor out the greatest common factor in order to simplify as much as possible. So I see x is a common factor. I see 1 plus x is a common factor. And now let's talk about powers. For x is power 1 and power 2, so I have to choose 1. For 1 plus x is power 4 and power 5, so I have to choose the smallest. So x is out, 2 is still in, and from those 5, I took out 4 of them, so there is 1 left. Now from this x, 1 of them is still there, so minus 5 and x, and all these 4 are completely out, and 1. If you want, you don't have to. Finally, x, 2 plus 2x minus 5x over 1 plus x to the 6th, which is x still outside, negative 3x plus 2 over 1 plus x to the 6th. I would prefer factoring out negative 1, and I have x outside, 3x minus 2 in parentheses, 1 plus x to the 6th. Now, if we want to determine the same thing, the derivative using the product rule, then I will have 2x times the second function, 1 plus x to negative 5, plus x squared times negative 5 times 1 plus x to negative 6 times the inner function prime, which is 1. Let's see what happens now, because we have to show that it's the same thing. So that's what we have so far. 2x, 1 plus x to negative 5 plus x squared times negative 5 times 1 plus x to negative 6 times 1. Okay, let's continue. I'm on page 13. So this is 2x over 1 plus x to the 5th. And this is minus 5x squared over 1 plus x to the 6th. So then now I have to find the least common denominator, which happens to be 1 plus x to the 6th. This needs an 1 plus x. I'll distribute 2x plus 2x squared minus 5x squared. And then I get negative 3x squared plus 2x over 1 plus x to the 6th. And I will factor out negative x, and I get 3x minus 2 over 1 plus x to the 6th. And we have to show that they are the same. And here they are. Negative x 3x minus 2, negative x 3x minus 2 over the same thing. Final problem in this section, I would like to look at 81 on page 175. Compound interest. And we are given the formula. A equals 5,000, 1 plus I to the 3rd power. I is compound, okay, the rate I compounded annually in 3 years will grow to an amount, and we have that. Find the rate of change. So in part A, we're asked to find dA over di. We're asked to differentiate this function with respect to I, of course. So we have 5,000 multiplied by 3 times 1 plus I to 3 minus 1 times the inner function prime, which will be 1. So this will be 15,000, 1 plus I squared. And in part B, they want to interpret the meaning of dA over di, and this is the rate of change of the accumulated value with respect to the annual interest rate, I. The last section here deals with, it's 1.8, higher order derivatives. Like derivatives that are second, third, fourth, fifth, and so on and so forth. And I would like to look at a couple of problems here. I'm hoping again that you went through the section and you solved the examples and odd number problems and so on and so forth. So we can work on a few problems together, like for example 18 on page 182. We are given a function f of x, 2x to negative 2. They want us to determine dy over dx and then d2y over dx2. This is the first derivative and this is the second derivative, regardless of how you want to write it. So first, f prime is negative 4x to negative 3. And then the second derivative will be 12x to negative 4. So if you want to write it in the Leibniz notation, then d2y over dx2 is 12 divided by x to the 4th. For example, problem 38 on 183. We're given y equals x to the 5th. They want us to find d4 over d4y over dx4. First, of course, I have to find y prime, which is 5x to the 4th. Then the second derivative, which is 20x to the 3rd. And then the third derivative, which is 60x squared. And finally, the fourth derivative, which is 120x. So this is d4y over dx4, which is 120x. One last problem from this chapter. Let's say 46 on the same page, 183. We're given the distance formula or function, negative 10 t squared plus 2t and plus 5, where s is in meters and t is in seconds. Find each of the following. V of t. So part A, V of t is the velocity or the rate of change of distance with respect to time. Rate of change of distance with respect to time. So v prime of t will be negative 20t plus 2. Then they want us to find a of t. A of t, which is v prime of t or s double prime of t. So a of t is the rate of change of velocity with respect to time. Rate of change of velocity with respect to time, which will be negative 20. This is measured in meters per second, and this in meters per second squared. Sorry, meters per second squared. Very good. And there is part C, to find the velocity and acceleration when t equals 1 second. So from here, v prime of 1 will be negative 18 meters per second. And from here, the same thing, because the acceleration is negative 20. Thank you.